So in the previous example, we were looking at one variable and comparing the mean of that variable against a null hypothesis that was a number. So it was we had a belief about what the mean should be, and then we accepted or rejected that status quo. In a two-sample test, we're comparing the mean of one sample against the sample mean of another. So we're comparing means to each other rather than to a population parameter. So there's an important difference here because both those means are uncertain. And so it requires a different test, two-sample test. So if we go back to the height example, suppose we were sure that the standard deviation of height between men and women was the same, but we're guessing that the mean is different. So we suspect that men are taller than women, but we want to test this. So we would start with a null hypothesis that men and women are the same height, and then if we reject that, we would reject that they were the same and therefore conclude that they're different. When both means are uncertain and the variance is assumed to be the same, that this test that we would do, the appropriate test, is a pooled variance t-test. This in PSW is listed as an independent t-test. And the independent t actually reports both under the assumption that the variances are the same and that the variances are different. So you just read the appropriate line on the output. So we don't have height data to test, but we do have our restaurant data. And we have two groups in our restaurant data. We have restaurants in the city and restaurants in the suburbs. So we can ask the question, do restaurants in the suburbs have better service than restaurants in the city? So our null hypothesis with that would be that they aren't different, that they have the same levels of service, and then we could either accept or reject that hypothesis based on our data. So if I jump to PSW, let's see, and I've got my data set here. So I'm going to now notice here I've got location, I have city, and I have suburb. So I'm going to run analyze, compare means. Now instead of doing a one sample test like I did before, this is the independent samples t-test. So I've got, I'm going to do this fresh. So I want to group by location. So I've got, here's this variable location. It's, all right, so sorry, excuse me. So location here is my grouping variable. So I'm going to put that, I've clicked location, and I'm putting it into the grouping variable. But now I need to define the groups. So I click the define groups button naturally, and I have two options. So, in these dialog boxes here, you would enter the data that you want to put in group 1 and the data you want to put in group 2. So if you remember from our variable, our data is split evenly between data where the location variable is coded city and data where the location variable is coded suburban. So I've put city here and suburban here. So naturally, spelling is important here. And if you have more than two groups, you can't do it this way. So that requires a different test. But we have two groups, so I put city here and suburban here. Continue. So I've defined my grouping variable. I'm comparing restaurants in the city to restaurants in the suburbs. And the question was, are service levels different between the suburbs and the city? So our null hypothesis is that they were not. And then we might be able to reject it. So here's my results. Let me get it down to a manageable size here. So let's see. So here we go. I've got city and suburbs. I've got 50 examples in each. And so the service levels in the city were 19.24. The service levels in the suburbs were 19.82. So service in the suburbs was a little better. So the question is that different enough to reject our null hypothesis that they were the same? Okay, so first thing you'll see right away is we have this Levene's test for equality of variances. So we made the assumption that the variance of city and suburb were the same. This test, we fail to reject here. So this is a high, so this F statistic, F is like a T statistic for this test in the sense that, the bigger the F, the more strongly we would reject the null if we can. So this F is small. We have a large number here, so we fail to reject equality of variance. So our assumption that the variance was equal appears to be justified based on that test. So now we'll go over, and that means we can use the equal variance as assumed row. So if this had been rejected, we would need to use the not assumed. But our assumption was appropriate. Equal variance is about right. And so the T statistic for our test is negative 1.2, significance of about 20%. So while the city and suburb do have different levels of service, we're not confident that that difference is not just due to randomness. So given the sample that we have, we would not reject the null hypothesis that the service levels are actually the same. So even though there's a difference, it's not different enough to make any meaningful conclusions, at least at the 95% level.